All right, let's get started. I don't have exams back. I honestly still have one more exam to collect, so I'll probably be giving exams back on Friday. And if you're not coming to class on Friday, you can stop by my office and pick up your exam on Friday if that works for you. So, yes, sir.
When would you be open on Friday?
When would I be open Friday? From 11 to noon for sure, or set up an appointment in the afternoon. So either of those is fine. Okay, so today I want to talk about antiderivatives or any questions that you have on antiderivative homework. So any questions? Yes, sir.
55.
55. Let's take a look. So 55. Oh, yeah. So on 55, we have the antiderivative of 4 divided by x times the square root of x squared minus 1 dx. All right. So first of all, we have this 4 on top. And 4s, that 4 can move in and outside of that integral. Okay, so I could write it this way, that it's 4 integral 1 over x square root x squared minus 1 dx. Now, does that guy look familiar at all? Yeah.
It's the derivative of secant inverse x.
That's right. It's the derivative. That thing's the derivative of secant inverse x. So if I'm taking the antiderivative of this guy, although usually we say an absolute value around that x when we do secant inverse of x, but in this case, since it's just an x, but that's okay, as long as we're considering that that x is positive, everything's fine, and we could write that this is 4 secant inverse x plus c, and that's it. Other questions? Yeah.
79.
79. We have, okay, so this is an initial value problem. Let's see. We've got g prime of x is equal to 7x times x to the 6th minus 1/7, and g of 1 is 2. Oops. G of 1 is 2. Okay, so we're given the derivative function, right? And we're wanting to find the original function. So the first thing I could do is I could say g prime of x, I could multiply this out, and this is 7x to the 6th minus 7 times 1/7 is just 1, and so just minus x. Yes.
Wait, what is that in x?
Oh, I'm sorry. That's a 7, right? Is that it?
Yeah.
Yeah, sorry. You're right. Okay, so 7x to the 7th minus x. Correct?
Okay, yeah.
Okay, so this is much better to take the antiderivative, obviously, than the way that it was before. So I just have to use kind of the reverse power rule. So I could say then g of x is equal to the antiderivative of this 7x to the 7th minus x dx. Or it's one of the antiderivatives, I should say. But that means that g of x would be equal to, let's see, I bump up the power by 1 and divide by the new power. So I get 7/8 x to the 8th. Then I bump up the power on this one. That would be x squared divided by 2, or times 1/2. So minus 1/2 x squared plus some constant of integration. Right? Now, the key here is that I would kind of like to know what is c. I want to know what c is. And the way that we find out what c is we use that g of 1 is 2. So we know that if I plug in 1 for x, I should get out 2. So I have the 2, or I could say g of 1, which is 2, is also equal to plugging in 1 for x. So if I plugged in 1 for x, I get 7 over 8 minus 1/2 plus c. And I know that that is 2. So now I just need to solve for c. So let's see, we get 2 equals 7/8. And 1/2 is also known as 4/8. So this is minus 4/8 plus c. So I get that 2 is equal to 3/8 plus c, or 2 minus 3/8 is c. 2 is 16/8. So 16/8 minus 3/8 is c, and so we get that 13 over 8 is c. So what's my final answer? We'll go back to g of x and put in what c is. So g of x is just equal to 7/8 x to the 8th minus 1/2 x squared plus c, which is 13/8. And we're done. Make sense?
Thanks, Jeff. So the instructions for this one, it says, I believe, the initial value or something like that.
Yeah, let me see what it says. Find the solution to the initial value problems. Yeah, so what they're saying is this is the initial value part. And it's saying, like, if you take an antiderivative, I probably talked about this in the video, that you actually get infinite solutions because the c is unknown. So this is actually, when I write down this, I'm actually saying there are infinitely many functions that have that derivative. One for each constant you put there. This could be 1, it could be pi, it could be 37, all sorts of things. But it's like, no, there's just one of them I'm looking for. But you can figure out the one of them that you're looking for if you know one point on the curve. And so if I know this one point, then I can use that one point to find, no, this is the exact function I'm looking for, and I know what the constant is. Does that make sense?
Yeah.
So that's an initial value problem. It's kind of like, okay, I need you to take an antiderivative, but then I need you to use some initial point to solve for the constant. And that's it, yeah.
Okay.
This comes up actually a lot in physics. In physics, a lot of times you need to solve some sort of an initial value problem, or in differential equations, which you haven't taken yet, but someday you will. It's kind of like, a lot of times you can find like a family of solutions, which is like this. That's like a whole family of solutions to the problem, but you're looking for the specific one that satisfies some initial condition. And yeah. Any other questions? Yeah. 41. Okay, 41. We got 2 plus 3 cosine y over sine y squared. Okay. Could you read that to me? So 41, it was integral of what?
2 plus 3 cosine y over sine squared y.
Over sine squared y dy. Okay. So I think we need to rewrite this. So first thing I see is this is integral of, we've got 2 over sine squared of y. So let's just rewrite it as breaking it into 2 fractions. So we've got 2 over sine squared y, and then we've got plus 3 cosine y over sine squared y dy. I'll rewrite again. This is integral of 2 over sine squared y is also known as 2 what? What's 1 over sine? Yeah. Yeah, cosecant, right? So this is 2 cosecant squared y, right? And then this one, I've got a cosine over a sine, so plus 3. What's cosine of y over sine of y? Cotangent of y. So that's cotangent y, but I've got another y on the bottom. But 1 over y, we just said was cosecant. So this would be another way to write this. But this one, we actually do know something whose derivative is cosecant squared of y. Sort of.
Negative cotangent.
Yeah, negative cotangent. Okay, let me think about that for a second. Yes, negative cotangent y would have the derivative cosecant squared of y. So this is equal to, the 2 does nothing. And then the antiderivative here is negative cotangent y. Again, the 3 does nothing. And then whose derivative is cotangent y, cosecant y? Cosecant of y. Cosecant y plus some constant. I'm lying. Something's wrong. What's wrong? Yeah.
The cosecant is supposed to be negative.
Yes. That's negative. Because the derivative of cosecant of y is negative cotangent cosecant, not positive. So I need that one to be negative as well, just like I did this one. So now that's, everything is good. I could rewrite it if I want to and move the negatives outside, but that's basically it. Okay. Other questions? Yeah. 51. Okay, so 51 is just integral of 1 over 2y dy. So 51, we have integral of 1 over 2y dy. And one thing we could do right off the bat, if we wanted to, is we can move the 1/2 outside. So we just get 1/2, 1 over y dy. So the question is, what's the antiderivative of 1 over y? Is there anything whose derivative is 1 over y? ln of y. Yeah, and what we have to do here, though, is we have to be just a little bit careful. It ends up being 1/2 ln of the absolute value of y plus c, not just y. And the reason for that is we don't actually know that y is a positive number. And you can't plug in negative numbers to ln. Only positive numbers go into ln. So this actually ends up working out. If y is positive, then its derivative is 1 over y. If y is negative and you take that derivative with an absolute value, it ends up that its derivative is 1 over y. So it works in both cases. So this is actually kind of important that as we take antiderivatives and we get ln's, always put an absolute value around the antiderivative piece here, ln of absolute y, not y. Okay. What else? Yeah.
Can we do 81?
81?
Yeah.
Sure.
It another one of the initial value of.
Oh, okay. So we've got 4 cosine u minus sine u.
So this is 4, what was it, 81?
Yes.
Okay, f prime of u is 4 cosine u minus sine u. Is that correct?
Yes.
Okay. And f of pi over 2 is 0. F of pi over 2 equals 0. All right. So first of all, let's take an antiderivative. So if we want f of u, then that's going to be the antiderivative of 4 cosine u minus sine u du. And if I wanted to, I could just bring the 4 out of the integral and not deal with that the second. So 4 integral of cosine u minus sine u du. And I know when I was first learning antiderivatives, this is something I really kind of had to think about. And that is like, okay, I know the derivative of sine and cosine. So what's the antiderivative of sine and cosine? And you kind of have to think backwards about what I always do is I'm like, okay, who's the guy whose derivative is cosine? So if I take the derivative of what, do I get cosine? Sine. That's right. The derivative of sine is cosine. So this is going to be equal to 4 times the antiderivative of cosine of u is sine of u. The antiderivative of, okay, whose derivative is negative sine of u? Cosine. Yeah, the derivative of cosine is negative sine. So this is plus cosine of u plus some constant. Correct. So this would be all of the antiderivatives. I need a particular one where f of pi over 2 is 0. So this is f of u, and I want f of pi over 2 to be 0. We know that that's true. So what is f of pi over 2? Well, it's 4 times sine of u, or in this case, sine of pi over 2, plus cosine of pi over 2, plus some constant. So 0 is equal to 4 times sine of pi over 2 is what? Yeah, just 1. And cosine of pi over 2? 0 plus c. So this is just 1. So we have 0 equals 4 times 1 is 4 plus c. Or c equals negative 4. And now I can write my function. And that is, it's up here. I just need to replace c with minus 4. So I have f of u is 4 times sine u plus cosine u minus 4. And that's it. Yeah.
I'm wondering if you want to make the parentheses a little bit longer and like take 4 out of the minus 4, wouldn't that still be the same? Like, 4. I mean, if we have.
Oh, could I have like put this inside as like a minus 1?
Yeah.
Yes, you could have. So another question that comes up is like you had 4 times an integral. Why didn't you do 4 times sine u plus cosine u plus c with the c inside the parentheses? Why did I put the c outside the parentheses? And the answer is because it's a constant and I don't care. It's like 4 times a constant, 4c, and c That's the same thing, right? For constants and constant, it's just a constant. So it doesn't matter if it's sitting inside the parentheses as a plus C or outside the parentheses as a plus C. It's just plus some constant. So it doesn't really matter in this case. Okay. Other questions? 53.
All right. So we've got integral of 6 over. Okay, let me try to, let's just walk through this one just verbally instead of me writing. So on the top, obviously I could factor that 6 outside. So then we have a 1. On the bottom, we have 4s underneath the square root, but we could factor those 4s out. And what would they be on the outside of the square root? A 2. So you could pull that 2 out and you'd have 6 over 2 on the outside. But then on the inside, you just have 1 over the square root of 1 minus x squared. But that's sine inverse of x. So it's just going to be 3 sine inverse x plus c.
Okay, so you can factor out the 4 from both of them and then pull it out of the square root?
Yes, as a 2.
Okay.
Yep, that's right.
But if you pull something out of the denominator, it's also pulled out as the denominator.
Yes, definitely. And that's an easy mistake to make, is kind of like, but it's clear. I mean, if you have 1 over 2x, you would never really say that that's 2 times 1 over x. It would be, that's bad. It's 1 over 2x is equal to 1/2 times 1 over x. Right, so you pull it out as a 1/2, not as a 2. You just have to be careful on that, but yeah. Okay, I actually think that that's a pretty good place to stop for today. These problems aren't super hard, and between what I've shown you today and what is online, I think you have everything you need to complete your homework. I'll post a new assignment. It's not posted yet. The homework, I'll get it done today, this morning, and so that will be ready to go. Obviously, we don't have class on Wednesday, and so I won't see you again till Friday. So have a good mini break. Yes?
Do we have homework on Wednesday or Friday?
Friday you will. Yeah, you'll have an assignment due on Friday. Yeah, so we're almost done, right? So you'll have an assignment due on Friday. We have like about 4 sections left to cover. And so we'll have an assignment basically every day. I don't know if we'll have one due next, not this Friday, but next Friday. I don't know if there's one due that day or not, but it's pretty close.
So this next upcoming one will be due Wednesday. Or is that due Friday?
Friday.
Okay.
Yeah, nothing due Wednesday. Nothing due Wednesday. We'll talk about the next one on Friday, and it will be due on Friday. Yep. Okay, have a great day. I will see everybody on Friday.